I'm going to do the odd numbers of geometry 10.5 homework, and you guys are assigned to just do the even numbers. Now I'm going to do the odds so that you guys have good examples, but I want you to figure out the even ones on your own based on the examples that I give you. So here we go. Follow along if you need, otherwise just skip right to the odd ones, or the even ones, excuse me. So number 1 tells me that I have an octagon with side length 6 centimeters. Now in this homework we're using trigonometry. So let's do this. I'm going to insert an octagon. Where are my shapes? And good. Now I'm going to bring it over here. I'll give myself a little bit more space so I can make this larger. Fill it with nothing, and we have a side length of 6. Okay. Now what we need to know is maybe I should fill these in with Now I'm only going to draw 2 of these just so I get one of the triangles. Okay. Now what I need to know is what is the length of that apothem. Okay. Now what I know is that I've just made a right triangle right here. And I also know that I can figure out what each of these angles are. And that this angle is half of what one of those angles is. So how I find that each interior angle is by finding the sum first. So I take the number of sides minus 2 times 180. Number of sides is 8 minus 2 times 180, or 6 times 180. I'll see what that equals. That equals 1080. And since there's 8 of those interior angles, I divide that by 8 to figure out what each of those would be, which is 135. So this right here would be 135. So would this be? So would this be the whole thing? But I only want half of it. So I'm going to divide that by 2. And I get 67.5 degrees. Now that's a little bit funkier than what we've been used to working with, especially in 10.3. So how I'm going to find the apothem is by using what I know about the side lengths and the apothem, and then a little bit of trigonometry. So I know that the apothem cuts that side length in half. So this right here would be a length of 3. I just figured out that this angle is 67.5. What I'm going to do is draw that little triangle a little bit larger. So the right triangle here is going to be redrawn with a right angle there. This is 67.5 degrees. This right here is 3, and I want to find the length of the apothem. What I realize is that if this is my angle of interest, across from that, that's my opposite, and then next to it is the adjacent. These are the sides that are going to tell me what I use, which trig function I use to figure out the length of x. Opposite and adjacent, that is TOA, or tangent of the angle equals opposite over adjacent. The angle is 67.5, so tangent of 67.5 equals opposite x over adjacent 3. To get x by itself, you multiply 3 by both sides. What happens is the 3 just moves over to the other side. So it's 3 times the tangent of 67.5. A lot of work just to find that apothem. But that's what we'll get when we do that in the calculator. 3 times the tangent of 67.5 equals 7.24. Now that I have the apothem, I have to use that in my equation. I'm going to move this stuff even further down. In my equation for the area, let me undo that. Area is equal to 1/2 times the apothem times the length of one side times the number of sides we have. So it's going to be 1/2 times 7.24 times the side length, which we said was 6, times the number of sides, which is 8. I got an area of 173.8 square centimeters. Make sure you review all the way through this to do number 2. When you do number 2, you should get an answer of 84.3 square inches. Good luck with that one. Now I'll do number 3 for you. Yeah, I'm going to do it. I'm going to move 4 down so I can just get everything all in one bunch. So, hexagon with a perimeter of 60 meters. Let me put a hexagon in. There we go. 6 sides. And if it's 60 meters all around, and that's 6 sides, divide that by 6 to get how long each side length is. So there will be 10 meters each side. If I draw a triangle in, and then I draw my apothem in, I know that if I create a right triangle, that is this triangle right here, that the length of just this would be 5, which is half of 10. And I know from before that this is a 60-degree angle. I don't know why I wrote 30. And we're trying to find x. So let's use trigonometry. If this is the angle of interest, 60, across from it is the opposite. Next to it is the adjacent. And we are using opposite, adjacent, tangent. So the tangent of the angle equals opposite over adjacent. The tangent of the angle is 60. is equal to opposite x over adjacent 5. Multiply the 5 over to the other side to get x by itself. So x, or the apothem, is equal to 5 times the tangent of 60. When you multiply that out, you get 8.66. So that's what we're using as our apothem. And remember, the area formula is equal to 1/2 times the apothem times the side length times the number of sides, or this is also the perimeter. So area equals 1/2 times 8.66 times 10 times 6. And I got an area of 259.80 square meters. And that is 59. Good luck with number 4. For number 4 should be similar to the way I did number 1. Similar steps. Okay. Now, I want to find the area of each regular polygon, so I'm going to do number 7 and number 9 for you. Decagon with a radius of 10. So let's insert a decagon. So we have decagon is 10 sides. With a radius of 4. So if I were to draw my center, then draw my radii in, these are a length of 4, and then draw my apothem in. I have a right triangle right there. I'm going to redraw it just bigger so I can work with it easier. And I can figure out what this angle is right here, because it's half of what any of these interior angles are. So to find the interior angles, I do n minus 2 times 180. The number of sides is 10 minus 2 times 180. And that equals 1440. Divide that by the number of interior angles, which is 10. And that equals 144. And then I realize that this right there is half of 144. Divide by 2, and you get 72 degrees. So this little angle right here is 72 degrees. Now we can use trigonometry. If that's the angle of interest and that's the opposite, which is the side we want to know, and that's the hypotenuse, we can use opposite and hypotenuse, which is sine. So the sine or sin of the angle is equal to opposite over hypotenuse. The angle is 72 degrees. The opposite we do not know, but the hypotenuse we know is 4. So keep x on the right side, move 4 by multiplying it over here. 4 times the sine of 72. See what that equals to figure out what the apothem is. And you should get an apothem, or height of this triangle, being 3.8. And that would be centimeters also. Now we're not done yet because we have to use that apothem to figure out the area. So area is 1/2 times the apothem times the side length. Oh wait, we don't know the side length. We don't know this. We know how high this triangle is, but we don't know this. So once we figure this out, is 3.8. Now we have a new x. We have to figure this out. Well, this is our adjacent. Then using adjacent hypotenuse, that would be cosine. Cosine of the angle is 72. Cosine of 72 equals adjacent x over hypotenuse 4. X equals 4 times the cosine of 72. Which is 1.236. Now, if this part is 1.236, the whole side is twice that. So each side of this has a length of 2.472 because I doubled this. That's my side length. I know my apothem of 3.8, and that's all I need to know. So we're going to plug it into the area formula now. And I'll say area equals 1/2 times the apothem times the length of the side times the number of the sides. So 1/2 times 3.8 times side length is 2.472 times the number of sides, which is, if it's a decagon, that's 10. Multiply that out and you should get an area of 46.97, which we'll just round it up to 47.0. That would be square inches. Go ahead and do number 6, number 8, and the next video might have number 9 on there.